Good evening, everybody. So I'm Jeremy. I'm a director at Ally for C3 Customer Care and Communication. So our division owns things like the chat online, Salesforce, which we use for our desktop, for all of our agents, any of our customer processing, and then we also own Genesys and Avaya, which are our two IVR and agent phone systems. And then we own a bunch of glue systems in between, right? Stuff we build in AWS and just kind of tie everything together. So I run SRE and DevOps, got a team of 8, great team, and really love what I get to do there. How many here know what DevOps is? Cool. And SRE? All right, so easy way to explain it. Despite what the average definition I give during an interview is, which is, it depends on what your boss in the company thinks it is, right? Which if you're in the industry, you really do get. But DevOps technically is supposed to be that part of accelerating developers, right? And putting things into production. So my DevOps team is called Accelerati. My Illuminati team, they are my SREs. They own everything after it's in production, right? So they own the observability, they own any incident issues that come up. Obviously, our DevOps staff helps, right? And then they own like PagerDuty and Datadog and Splunk and all of those really fancy tools that we use for observability. So tonight we're going to talk about observability. And this is probably the one thing that I run into a lot. I had a fellow director tell me, our system will never go down. So, not true. Everything will go down. Everything, right? We've seen outages for S3. Who remembers the AWS S3 outage? What, 4 years ago, right? AWS S3 went down. What happened? The status page that told us that S3 was down went down. So a lot of interdependencies too, especially when you start talking about cloud services. So if S3 goes down, by the way, you're not spinning up an EC2 instance, right? And you're not spinning up anything in a container because ECR and image storage for EC2 instances are all S3 based, right? So a lot of interdependencies that go on during the cloud that really can haunt us. So we'll talk a little bit about what we're going to go through tonight, talk about what we monitor and why, talk about production reliability, auditing your monitoring, and then finally getting started, how to start that conversation, how to start that work where you are. So logs versus metrics. The very basics of what we do in observability is watch things. And that's going to be anything from systems to hardware to people and traffic and anything that we can get our hands on that's a number that we can use for indication, right? And our goal, by the way, any good observability has one single goal. Your tech department knows what's going on and that you have an outage before any customer or any product owner or any person at all in the company knows. Your job in observability is to know first, to be the person that's messaging that out, to be the person that's spinning up the support, to be the person that understands what's going on and what that impact's going to be. And that's harder than you think. So talk about logs versus metrics. How many people here have looked at application logs? How many people have written an application, they throw a little log out, do a console.log or a little print statement here or there, right? So in the big bad world of enterprise software, we collect all those logs and we throw it into a huge system, right? Ours is called Splunk. I've worked with a bunch of other systems, Sumo Logic being my favorite. And I'm working with Splunk now. logs are descriptive, human readable, often just bits of information, right? They tend to be repetitive because they're driven out of code. So the same error message produces the same log most of the time, right? So you can go through and you can do things like count them or figure out if they're happening, is there an error? How many errors are there in 15 minutes? Those kind of things. On the flip side, we've got metrics. Metrics are different. Metrics are measurements, right? And they're about what's happening in a numerical sense. How many people came to the website? How many times did a Lambda get invoked? How many times did I give a 500 error, right? How much memory am I using on every call? Those kind of things are metrics. The difference is metrics are really standardized across the board. Whereas logs, I can put anything into a log statement. So if I'm building something out new, I can put anything in there that I want, I can see it. But if metrics require me to have a little more forethought, right? You can do custom metrics. We do it all the time. We just built a brand new health check system that does it, and it's great. Yeah, so, and metrics are aggregations over a period of time. So many things happened in so much time. Logs versus metrics. Does that make sense to everybody? Awesome. So individual logs allow us to pick out the singular events, right? So you might have a log statement that says this happened and also provides some customer information or some, we like to use unique GUIDs for transactions because they're unique. They can be logged. They're not PII. And so they're not your social security number. They're not your this. They're not your that, right? But there's some unique identifier. I can go back into a system and I can tie that log statement back to a customer if I really need to. So when we chain those things together, we can see a course of events. I've worked in systems where you literally type in a GUID and it'll show you from the front end transaction all the way through to the final transaction. Everything the customer and the system and the third-party vendors, everything they did, all in one complete book. Now imagine the power of that when you're trying to figure out what's going on. Where did it stop? What broke, right? So that's the power of logging. We look for errors. One of my favorite interview questions, what would you do if you had 2 hours to prep for a new launch of software and you could look for logs? What would you do? Obviously, you're looking for the word exception or error. I mean, right? It's the first thing you're looking for. Not only that, but actually, you can look for the absence of logs. So we look for logs. We're like, hey, there's logs here. Wait, there's no logs. We used to have systems that the servers were, we're replacing them next month. They're almost dead. We're restarting the app server every 12 hours. And if we have to, we'll kick it during the day. One way we did that was basically we looked at the log count from each of the machines. And when one of them started to dip, we'd immediately reset its app pool. So the Azure guy here is laughing at me. It's a good old Windows machine, right? You got to kick it every once in a while to keep it sane. So we look for the absence of logs, not just that we have logs, right? That tells us things are working and that they're not working. Not only can we look for the absence of logs, we can track users, determine where they're leaving. For example, if you're selling something and you see people adding things to their cart and then not checking out, if you know what page they were on last, you're tracking that information through. Hey, they went through the funnel and we lost them when they put in they started putting in discount codes. They couldn't find one they liked. They bailed. So, maybe the answer to that, if you're getting 100 or 200 of those a day, is maybe you need to offer them a discount code to come back to the site, right? So, any questions about logs? Metrics. Like I said, yeah.
I'm sort of like old school in that anytime most of the places that I've worked, logs were always something that took up too much space. Has that changed?
So,
And it costs like not just took up too much space, but it also costs the system, that lag because the log will turn on.
yes. 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 So the question, if you didn't hear it, was when we store logs, there's a certain amount of cost, both from a system perspective, you're moving that data, you're putting it somewhere, but there's also typically a cost for the ingestion of logs, whether that's Datadog, Splunk. Most systems cost money at some point. Even open source systems cost hardware. They cost people to keep up and running, right? Open source, as we know, is not free. It does take maintenance, right? There's a lot of strategies going on. One of the things the industry started to do is turn logs into metrics. That doesn't always make them cheaper. But that's something that you can do. I've seen systems where you can hit an API and you can enable info logging on a service for a set number of hours. So what happens is you fire an alert. This system fired an alert. PagerDuty would get it. PagerDuty would then see it, and it would fire an API call, and it would change the logging level for the next 4 hours to info. So by the time I was called to look at the logs, I had info logs. The advantage being that I was on air logs every other time of the day, right? And so those kind of systems could be advantageous. They can be difficult to implement depending on architecture. Lambda, no big deal, right? Especially if it's not persistent. Just put it in the environment, It'll change it the next time it runs. It'll log differently. Containers become a lot of different, right? And cost too. We've seen systems where they're like, oh, we're going to drop every 1 out of 10 statements, or they're going to look at, for example, Datadog can ingest logs and then drop things you don't need. So that can be handy if you're pulling in Lambda air logs and you don't want the start, end, or report. Or maybe you just don't want the start and end log. Well, save a lot of money by not logging those. So yeah, there's cost involved in it. There's definitely some strategies for doing reduction. There's new systems out there that are like, ooh, we'll use machine learning to analyze your logs and all that other stuff, right? Just Kafka behind the scenes, don't kid yourself. But yeah, there's a lot of strategies out there to do that. But you're right, they cost money, which is why when we log, we often use a logging level. So when I'm debugging, I'll use debug or info. When I go to production, I'm looking at air logs only. That way, when I'm working on the software and develop, or even in non-prod, I can adjust my logging level to be more verbose, where in production, I'm only looking for errors and fatal events, right? So it's a great question, very relevant to the logging. Any other logging questions? All right, metrics. So there's a lot of metrics that are provided nowadays by our cloud systems, whether it be GCP or Azure, or where my strength lies, which is AWS. They all have built-in metrics that'll tell you anything from how many of this is happening on what, where, when. Not entirely exhaustive. For example, in AWS, you can't tell how much memory is left on an EC2 instance natively. You can't tell how much hard drive space is free on a hard drive in an EC2 instance natively. Their software allows you to do it, does not come out of the package. So there are limitations. I can look at CPU, I can see whether the system's up or down, right? I can look at network load, all very relevant. CPU's 100%, network load 0, what happened? System's crashed, obviously. So very useful. But the reason metrics are so cool is they're very easy to alert on, right? So it's easy to say, okay, I have 10% of my traffic is 500 errors. Might have a problem, right? That kind of information allows us to be very easily set up alerts. And be careful, especially when we're talking about front-end systems. Bots and things like that can really wreak havoc with those kind of numbers, those kind of strategies. Attacks and stuff often are found that way through metric systems. And metrics tend to be less expensive. Not always. They tend to be less expensive and easier to alert on. So, questions? Awesome. This is the easy stuff. So, obviously, we live in a cloud world. We have two basic ways we look at our hardware out there. Either a server, virtual, hardware, doesn't matter, EC2 instance, bare metal, whatever. And then cloud, right? Serverless, whether that's Fargate, which is serverless serverless containers, or Lambda, or even databases are now serverless. Obviously, memory usage, very big deal. Hard drives. How many people here have had a hard drive fill up in production? How many here have had a hard drive fill up in production monthly for at least 3 or 4 months? That's right. You're the real heroes here. Box health, whether the box is up and running, whether the box is alive, is it passing traffic? Can I hit it, right? How many times is your laptop locked up and you can't do anything with it, right? Being able to detect that state is important. Not as easy as you would think for a virtual environment. And finding the cause can even be worse, because it can be anything from a kernel panic to simply overloading the system, to fail hardware, right? Kernel panics being the most notorious to troubleshoot, especially in a cloud environment, right? And then obviously CPU, right? So CPU just tells us how much work a system's doing. And this is how we generally think of a server. Questions on monitoring servers? All right. Serverless. What? Yeah. Yo, it still runs on a server, dude. Yeah. So I have been spending the last year of my life in serverless. I haven't spun up an EC2 instance in production in over a year. Thank you, thank you, thank you, thank you. I love it. Why do we love serverless? I'll give you a little rundown. One, how many people here have ever done a PCI audit or a SOX audit? Yeah, let me tell you what, avoid it like the plague. Can you tell me what happens when you leave the system alone for 15 minutes? Does it automatically log you off? And can you provide proof? You think that's bad. It's worse than that. How many of your systems have VPN that keeps your systems from... It's crazy. Now, try working at a bank, investment company, lender, mortgage lender, auto lender. You think regulation is tough anywhere else? Whew. All right, so I am more than happy to let AWS run all of my backend, all of my updates, all of my patching, everything, and just consume the service as I need it, right? Serverless is expensive for static loads, right? Things we run all the time. Why? Because it's amazing. It saves at least 2 members of my team from having to do just audit work and updates and boring stuff. When we look at serverless architecture, when we look at how we're using that today, it's obviously pay for what you use. And this is great because, once a night you might have to go grab a file, hit an API, download a file, store it in an S3 bucket. Just archival information you might need. Every 5 minutes you want to go hit an API, grab some information, throw it in a database, right? I don't need a whole server to go grab an API request, to make an API request, grab the data and throw it into Dynamo or something. I don't need a server for that. It takes me less than a minute to do in a Lambda, spun it up every 5 minutes. Might cost me pennies a day. Pennies, right? So there's the big power of serverless. We worry about memory, obviously. We're about processing time. We're about connections and queries. And we worry about scaling up because serverless costs more than running a bunch of servers. When you amplify that, at some point, when you start running millions, it starts to take a look like maybe I should go to containers when you're on Lambda. When you start running billions, then you start looking at how much does it cost for me to have these people to do these things that need to be done? And is that cost less than, is that cost enough that my savings will make up the difference, right? A couple things about serverless from things I've worked on in the last 6 months. Very simple. Whenever we have a serverless issue, it's normally one of 3 things. It's normally AWS, and by the way, when there's an AWS outage, keep me honest here, you normally won't get them to admit it for at least 20 minutes, right? So you're driving yourself mad for 20 minutes going, why doesn't this work? The second thing, upstream services. I'm not down, but the system I need to talk to, the API endpoint, the vendor, wherever I'm going with this, they are down. And that makes me look bad because I am now down because they're down, right? That's why it's very, very important when you're monitoring things, don't just monitor yourself. Monitor every one of your partners. The number of times I've had to call partners and go, your requests are taking 10 times more than normal. Would you please check your systems? And I get the little college newbie going, there's nothing wrong with our systems. How dare you infer that there's anything wrong with our systems? We're the best. And then 30 minutes later, you're on the phone with their network engineer going, I called Jason half an hour ago. Did he not tell you that I said that it sounds like maybe your database is going to crash? And anyone here who's run against a real database is like, yeah, I've been there. The third one, bugs. It is the world we live in. This is where QA and test automation makes a whole lot of sense. I have literally shut down development teams. And by the way, to do that, you have to check with product, you have to check with your boss, you have to check with your senior director, you have to check with everyone around you to make sure it's okay to do this. I've literally shut down teams to say you're going to spend a month writing QA, testing, unit tests, functional tests, whatever, right? We're going to get your pipeline straight. We're going to get everything ready to go. We're going to do it right. With the right technology partner, that can actually be a very, very powerful thing to do. It's really great when it works. It is horrible when it doesn't. All right. Last but not least, we'll talk about APM. So, anyone here run APM on your systems? What do you run, if you don't mind me asking? Okay. What do you run? Dynatrace. Sorry. Bad memories? Dynatrace is good. It's just expensive. I've run Datadog, I've run New Relic, I've run Dynatrace, I run some other stuff that I can't tell you about. Application monitoring. So it hooks into the back door of your code, provides essential information. Think of it as measuring every time you're leaving your local scope. Going to a database, going to an API, going to a drive. Anytime you're not processing data inside of that little program and you leave, it's making notes. If the other systems have the same APM, they hook up to each other. This guy talks to his buddy, talks to his buddy, talks to his buddy, and all of a sudden you've got this huge network, right? Called a map. And it's amazing because if I look at a map, most APMs have this huge map, and they go red in the places where, you know what I'm talking about. You've seen the red, and you've cussed. I know you have, because I have too. So you see the red, and you're like, that's the connection to my database. And by the way, it's always the database. Always the database. You need something to blame, start with the database. So you get that red line, and it helps you identify where the problem is in your system, right? And by the way, this is all automatic. It's really cool, which makes it kind of expensive. We can see the transactions as they flow to and from different applications, right? And they're metrics based. A word of caution. APMs are notorious for sampling metrics and not actually looking at every single call. So they may look at 30 calls, take the min, max, and average, and use that, which makes it more difficult to see outliers. So there can be some finesse in how you look at this data. A big warning over here. Depending on your APM, depending on the code, be very, very careful with try-catches. Most APMs will capture exceptions. That's kind of how they work on a really basic level. They're looking for errors, looking for any time you leave local scope, and they're measuring that, and they're looking for these errors and exceptions. If you put them in a try-catch, what happens? They get caught by the system and not the APM, and you can't see them. So be very careful with try-catches in APM. I didn't say don't use a try-catch. That's not what I said. Please, try-catches are there for a very good reason. But just make sure you realize that we need to have a little bit of knowledge and may need to do a little bit of work around that. All right. Active monitoring. Certificate validation. How many people have had a certificate fail in prod? That's everybody in the room who's been in IT more than a year? Good. Simple web monitoring. Can I hit the website? Are the basic things there? Right? Very easy. Watchdogs and synthetics monitoring. Kind of related. A synthetic is a system that actively says, go to this page, do this thing, get information, make sure it's right. Kind of like a mini test. If you don't know how much testing, it's kind of like a big test. But it's used basically to repeat the same process, a login process, or looking at a certain page, or hitting a certain thing. And we use it because it tests website functionality. Not can I get there? It's testing, does it work? Which honestly is more important than can I get there, right? Is the Zoom broken on the website? Yes. Watchdogs are a little bit different. We talked a little bit about this in logging, where we looked for the absence of logs. Watchdogs can also be, they originate from microcontroller systems back in the day, where you would raise a line to this little microcontroller sitting over the side, or this little RC circuit, or whatever. And if you didn't continually hit that thing, or pet the dog, as they say, it would cause the system to reset. Why is that cool? How many people have had a system lock up a computer? Well, when that computer is running some really big equipment, or in a really deep hole or someplace you can't get to, a watchdog will automatically restart it if something happens. And we've taken that concept and we've brought it into the IT world. And this is me saying, I've got a system and I'm just going to have it hit an API every so often. And when it stops, we got a problem. It's a little bit more active than synthetics. It's not very much used, but for the systems you use it for, it's really awesome. Let me tell you a really awesome use for a watchdog. You got a logging system. Remember, talked about monitoring third-party systems. You got a logging system. You set up an alert that calls an API every 5 minutes because you have a search that always returns true, right? What do? You take that and you push it to Datadog's API for watchdogs. Now, every 5 minutes, my logging system is sending information to another monitoring system, and now they're watching each other. Now the logging system is saying, I'm alive, I'm here, I can search, I can do things, and it's hitting the watchdog. And the watchdog is like, hey, you're here, you're good, oh, cool. The moment that stops, we send an alert, your logging system is down. We think that's not possible. I was sitting at the Sumo Logic conference in my hotel room that morning, preparing to give my speech on what, I don't know what. I get an alert. Yep, Sumo Logic went down during their conference. Can't make that stuff up. How did I know? Because I had active monitoring going, right? I had a system watching another system. This is, by the way, kind of uncommon, but it kind of just makes sense, doesn't it? Observability. Certificate validation. One cool thing I've done in the past, which is really awesome. We had a system that communicated to 500 other systems. And we communicated, we sent them data over just a standard HTTPS API. Not every one of these systems had some high-class engineer on staff. A lot of them use third-party vendors, stuff like that. How many, and everyone's crunching, talking third-party vendors, not high-class people, and certs, yeah. We wrote into our code to do a certificate validation, and if your certificate was going to expire in 30 days, we sent an alert to the salespeople. Hey, ABC is going to have an expired certificate in 30 days. We'd send it again at 21, 14, and at 7, we start sending it every day. Why is this cool? Because before, the certificate would fail, and then we'd have to get online with the vendor, and it would take them a week or two to get back up and running. In the meantime, I can't sell them anything because I can't send them anything securely. That single act saved the company millions of dollars a year. Pretty simple stuff. All right. Any questions about active monitoring? Yes.
With that synthetic monitoring, are you basically just like talking about like literally an automation with Selenium or something like that?
Exactly. Except a lot of the newer systems, like New Relic's is best at this. New Relic, you go to a website, you have a little plugin in your browser, and you go through and you click, and it records the whole dang thing for you. Click a button, boom, you got a synthetic up and going. All right, we've probably blown too much time already, so we're gonna go a little bit faster. MC, how much time do I got?
I've got about 7:35. We can go maybe 15 more minutes, and then we'll
Sweet.
open it up to questions.
Okay, cool.
Here's my only favor here, is that as people ask questions, repeat the question back so that
Awesome.
we can get it on
Yes.
the recording.
Yes, perfect. Okay. The impact. Every downtime has impact, but it's different. I'll give you a good example. This is out of my new book. Yeah, I know. I'll tell you about that later. A customer does custom hats, right? And on their website, they got an API that generates the cost of custom hats based on your quantity, what the design is, how much ink you need, blah, blah, blah. And it's used during the pricing process. So as you can understand, it's really important that it always works. Because if you can't get a customer price, they can't check out. They leave the site, you lose sales, life sucks. On the flip side of that, every night you have a process that generates labels, shipping labels, send shipping information to the customers. Say fire it off every day at midnight. Warehouse crew comes in about 8. You've got 8 hours to make that happen, right? So you get a notification at 3 o'clock in the morning going, it didn't work. What do? Well, if it's the website, you get up, you go to your computer, you start going, you get it fixed. If it's a label process, you probably reset your alarm clock for 5 o'clock, get up, have a cup of coffee, grab a shower, and leave for work early. Why? Because you've got until 8 o'clock to fix it. Why rush? On the flip side of that, when we talk about reliability, it's important that we price out every customer. Why? It's obvious. It is not important, however, that we generate a label for every customer, because if in the morning I have to print out 2 labels by hand going to ups.com, the impact isn't all that big. So if 2 labels fail out of 2,000, no big deal, right? The cost to fix it could be, a couple $100,000 worth of dev time. Because it could be 5 different issues going on, right? That's customer impact in a nutshell. Each one of those has different revenue models for them. Each of them have different business needs. Each of them are treated a bit differently. They're both extremely important, no question. They're both different. That's 10 times better than this slide. Communication, both internal and external. I've had C-levels call me and go, Jeremy, should we shut down our spend on Google ads? When did I become the CMO, right? We get asked a lot of questions, what the downtime is going to be, how long it's going to take. Best answer I can tell you is give an honest assessment. And if you have to shoot, shoot long. And by the way, if all of your staff are sitting on Google and they've been there for 20 minutes, it's a 5-hour outage, okay? At least. If people want to talk about how you treat customers, there is no finer example than Johnson & Johnson's recall of every single bottle of Tylenol on the shelf and out of customers' houses because somebody decided to replace Tylenol with cyanide capsules. It wasn't their fault. They had nothing to do with it. Just some crazy person. Tylenol's response was, we care about our customers. We are not going to let any of our customers suffer. None of our customers will die. They pulled all their bottles. They offered to replace any bottle of Tylenol out there. They immediately started shrink wrapping. That's responsible for the cotton ball inside, the wrapper on top, that little pesky thing, and the wrapper around the outside. All came from this recall. In fact, it made customer safety a product feature in the marketplace. And it saved Johnson & Johnson. Cost them a lot of money. But that is the use case, the example that's cited when we talk about how to treat a customer, how to work with a customer when you've had an issue. Cost them billions of dollars. Wasn't even their fault. It's pretty big. All right. Auditing your monitoring. 4 different basic ways we do it, other than going in and manually just doing everything, which by the way sucks. But when you have no other way, that's the way you should do it. Monitoring as code is very awesome because it allows you to put that monitoring right in your Terraform, in your CloudFormation, whatever you want to use. Your monitoring becomes part of your code. It can be rolled out as a Terraform module. It can be rolled out in a number of different ways. I've seen it as a Python script in an application. Cloud systems and APIs. Let's say you got 100 APIs in production, front-ended by an API gateway in AWS. Why does nobody just iterate through all of the API gateways and create CloudWatch alerts for each one? And if you need something other than the standard, I don't know, use a tag to direct it, right? That still baffles me why we don't do a lot more of that. Tagging, Datadog's really big on this. I pulled in metrics, all the metrics have tags. Now I can use the tagging to do a whole bunch of things. I've used tagging to route. So if the tag has a team name, it goes to this person, has a priority level, tells me whether I wake them up at 3 o'clock in the morning or not. All of that I can do with tags. And then an audit. An audit is really simple, it is what it is. Take a look at everything out there and away you go. All right. Rolling out monitoring as code. This is kind of where the industry's at. Especially when you start talking about shops that do a lot of Terraform and CloudFormation. This is really one thing that's hot for them. And it's really easy. Basically, you're setting up a template. You're adjusting settings. You're rolling it out, seeing how it reacts. Rinse and repeat. Any questions so far? All right. Routing your monitoring alerts. We're going to go through this real quick, but this down here is the biggest issue today in the marketplace, alert fatigue. I literally had an engineer call me and go, Jeremy, find me a job at Ally because I'm done with 3 o'clock in the mornings. And I'm like, all right, I can do that. He accepted less money. He accepted a downgrade in position. All of that because he was done with 3 o'clock in the morning. We work really hard, especially when you have a team of people who, I joke all the time, it would literally take me longer to pass the background check than to find a new job. When you work with a team like that, and you're sending them alerts, 2 or 3 alerts a night, waking them up, you can bet they're not going to come and work for you very long, right? Or you better be paying them a whole lot of money, like twice to 3 times what they can get elsewhere. When we talk about this process, how many people in here have heard of OpsGenie or PagerDuty? Just a couple people working in corporate shops. These systems are great. Very simply, they allow me to send a priority message when it's a priority to people, yell and scream at them, get them up out of bed when it's a priority. When it's a priority. It allows me to keep alerts out of their phones, out of their minds, until 9 o'clock the next business day when it's not important. Well, that seems like a really cool trick, right? It's not that hard. We assign a priority level to everything as it comes out of our monitoring. We say, priority 1 can wake up at 3 o'clock in the morning, priority 3 can't. Priority 3 fires from 6 in the morning to 11 at night. Priority 4, 9 to 5. Now I have control over what I'm sending to my people based on how important it is. Remember the shipping label? Yeah, we need to wake anybody up at 3 o'clock in the morning for that. We wait until 5 or 6. The website though, I'm getting your butt up. It's just that simple. We use systems like PagerDuty and OpsGenie to do that for us. I've seen companies try to do it with a lot of other things. Emails, text messages. Slack is a popular one. Yeah, none of them give you the response time you need for critical applications. All right, how do you get started? All right, how do you get started? Start with the things that are most common. Error logs, HTTP access logs, pull them in, start looking at them. If log costs are a big deal, don't pull in your 200s. Create them as metrics. Why? 200 to 200 to 200, right? The only thing it tells me is your unique IP or machine type, and I can take a unique IP, I can turn it into a zip code and make it a metric. I can take the machine type, your browser type, and I can metric that as well. I really don't need 200s anymore these days. Look at what your cloud providers offer. AWS will tell me a lot of things about the systems. It's really awesome. And mostly they're free. CloudWatch alerts cost 15 cents a month per alert. Datadog. Anyone here use Datadog? Anyone here have a Datadog bill over $100,000 a year? That's, by the way, a very cheap Datadog bill. I'm not kidding. All right. If you want more, I've started writing a book. Don't ask why, I don't know. Sounded like a good idea at the time. My wife said you should do it. Read my book, Becoming a Rockstar SRE. I want to thank the marketing department at Packard & O'Reilly for coming up with what is the best title of a book I've seen in many, many years. I had nothing to do with it. We're publishing in early 2023. Should be fun. We're going through a lot of things, including things like why companies write crap code without alerting, or why they write buggy stuff, or why they push things to production. We talk about the business side, we talk about the alerting side, talk about a lot of things beyond just numbers. Because really the numbers don't have a lot to do with it. I could tell you all day long, bad QA costs a lot of money. There's no real metric that'll tell you that, right? So, yeah, anyways, this is the end of the presentation tonight. Time for questions. I don't know about y'all, but I don't think the blowers helped.
Well, I'll say this, I don't think the lights are helping. I think the lights are really hot. So,
I'm just full of passion tonight.
yeah.
It's all good.
Okay, cool. All right.
All right, over here.
Log aggregators versus using log aggregators versus writing or pushing your logs straight from your code to a repository. Do you have an opinion on options there?
So, yeah, you're talking about like turning logs into metrics or turning them into some kind of, pushing them through something like Kafka or something to reduce the log quantity versus storing the actual raw logs.
Or allowing some, like with Kubernetes, right? A lot of folks, when they make the change over,
They end up with 10,000 logs a second, yeah.
yeah, so one of the things that we look at is if somebody's written a bunch of scripts or a bunch of custom code to try to push logs somewhere, things can get lost versus if they use a log aggregator or log stack.
Oh, you're talking about the transport mechanism.
Yeah.
So what you're asking about is, how do I get the logs from my code to wherever I'm storing them? There's a couple things you worry about. The first one is timing. How lively do my logs need to be? And if you need lively logs, Kafka. I mean, just do it, right? Firehose, whatever you want, Kafka. I've seen systems use Lambda to push logs. It's really expensive to run that much Lambda. Newer systems are getting better that they're chunking them out instead of doing one log at a time. I've written a lot of code that writes its own logs to these systems, especially DevOps type stuff where I don't want to pull in a lot of other stuff. Works great when it works. Most of the time, I like to stick to what the vendor wants us to use, for the simple reason that if the log aggregation starts to fail, I don't want a vendor telling me it's my stuff. I want the vendor to say, well, Jeremy, what are you using for log aggregation? I'm looking at them and going, your stuff. So buddy, if it doesn't work, it's your problem. It's your support contract. It's your deal. Fix it. Help us fix it. Especially for systems that you're paying millions of dollars a year for. I can't stress enough, get your vendors to do as much as you can But in order to do that, you've got to keep with their practices. Other questions? Yes.
So I have never dealt with a system at scale as large as Ally. I imagine there's a bunch of machines running at multiple locations.
Yes.
That final destination of log storage. Do y'all have like multiple different nodes that it gets thrown into, and then maybe you have like a custom unit that makes sense of it all, or like?
I can't tell you specifically about the systems at Ally Financial.
Just a strategy. Yeah.
However, in large enterprise systems, it is not uncommon to use what we call clusters. Big groups of servers that do nothing but the same thing. Hundreds and hundreds and hundreds of servers that do nothing but the same thing. That's not uncommon. It's not uncommon in SaaS providers. Sumo Logic runs that way. It's not uncommon in big enterprise systems. It's the most common way to run that kind of system. Yeah. Other questions?
You've firehosed a lot of logs dealing with the flood data. What's the best way?
Dealing with the what data?
Flood data.
So when we're using Firehose and we're getting that flood of data, how do we manage that? Well, we've talked about the cluster, right? It's not uncommon to use something like a load balancer between the Firehose and the cluster. Basically, we're setting this log or this group of logs, because anymore we do group them together. We're doing multiple logs in one push. We're taking that logging group, pushing it here, pushing this one here, pushing this one here, pushing this one there, right? So from NGINX to a network load balancer to an ALB, whatever your flavor is, load balancing. It's the best way to do it. And oh, by the way, make sure your Firehose is big enough, because Firehose costs money the more we put through it. All right, other questions? Going once, going twice. Sold. All right, so I'm gonna leave you with one. I want to leave you with one final thought, and this is the final thought I always leave everybody. When you're dealing with observability, just remember, I don't have to watch everything. We don't monitor every pipe in a steam plant. We don't look at every fitting. We don't do that. When you're monitoring something, you want to pick strategic locations. You want to look at places where you may have issues in the past, but you do not, especially in Kubernetes, want to try to monitor everything. You will go blind. That's all I got. Thanks, everybody. You've been a great audience.